Hey, how's it going? Today I'm going to go over combination sum. This is a medium problem on Leetcode, and yeah, let's just get into it. I'll get into like how I would approach this problem if I was given it during an interview, and hopefully this helps. Alright, so let's go through the problem. Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Okay. And test cases are generated such that the unique number of combinations target is less than 150. All right. So I mean, just reading from this problem initially, I feel like we're just going to need to be coming out with like different sorts of, not necessarily permutations, but different, yeah, like combinations, not necessarily using each number to get the target number that we want. And so for this case, a common pattern would be leveraging backtracking. That is just going through like the entire array, grabbing a number, seeing if it works, and if we get to a point where it's just too big, for this example, if it's too big, then we have to backtrack and try using another number, or try like going back and using another number from before. It'll make more sense when I start writing it. But yeah, let's get into it. So first we have candidates here, an array of numbers, target is 7. I would want to have a result array, so let res equal an empty array, and then we can do another method. Let's call this helper. This will take the current array. Yes, it would take the current array, but it could also take index. We're going to take the index to indicate where we are in the array, and then cur will be the array that we're working with, and then target is already on the outside of the method, so we don't have to worry about that. So then we'll come here, and then now we have to think of what's going to be on the inside of our helper. How are we going to do this recursively and then when do we add to our result array? So I guess what we could do, instead of having, I was going to sum all the numbers together as or like add all the numbers during each iteration, but if I just go with like, say sum, and pass that through and have, let's see, we can do if sum is equal to target, we can do res.push of cur. And then we need to make sure we're not referencing the same array. So I'm going to do the spread operator to make this a new array of itself. And then once we do that, I mean, our helper is going to be called like this as well. So we'll have helper 0, current will be an empty array, sum will be 0. So sum will be added to as we iterate or do our recursive calls. So what do we want to do here? If sum is equal to target, so here I could do index will be the candidates. So if I were to call a method here, I would do index plus 1 possibly. We could do, well actually we could use the same number twice, right? So we could do index cur is going to have cur.push of candidates, index, and then we would have cur being passed in here. So now we're using the 2. And then the sum would just be plus this number that we just added. And let's see. So this one, we're going to have a case where we're iterating through each number. We're going to need to, every time we come back, we can either pop it or we're going to start adding more stuff. So in this case, we would want a for loop to iterate through the candidates, but we're going to start our iteration from index because we don't want to be reusing numbers. I mean, we can be reusing numbers, but we don't want to be doing redundant work. So while I is less than candidates.length I++. So that'll be there. And this will be that. So we're going to push our number into our cur array, but we also want to pop it in case we come back all the way. Say we use like 2 a number of times and it just doesn't work, then we want to make sure remove all those 2s, but we will probably have combinations where we try, like say for example we do 2 3 times, we'll be at 6, and then we'll try like other numbers where like we have 3 6 or 7. I mean ideally we'd be looking for a 7, but the idea is it's going to try these other numbers. And so we're going to do candidates.length and let's see, the numbers will be unique, right? Okay, cool. Distinct integers, yep. All right, so, and then after that happens, we're going to do cur.pop to remove the last element because we don't want to use it again. So this will come through. We have index is equal to 0. Do we want to increment index? Because we could potentially be using the same number twice, right? So if I were to try to do like a sample run of this, we would have 0 be the index, so 0, push 0, so we're going to push the 2, then we'll continue the same thing, we'll have index still 0, cur is 2, or array of 2, array of just the element 2, and then sum will be incremented, so we'll keep adding the 2, and then if we need to have our condition where we don't push it. So let's see, if sum is equal to target, but and then there's else if sum is greater than target, then we don't want to continue, so we're just going to return. So that way we'll call this method, say we add a 2 again, which will equal an 8, so we'll come here, 8 is greater than target, so we'll return. This will come back here, we'll pop it, and then we'll try the next number. So instead we'll try the 3, and then so forth. That should be the case. So if this is confusing, try to go through like a sample case. So like the one I was talking about where we have 2. So I'll have a 2, and let's actually just generate it. So I have a 2, and then I'll add another 2 with my second call, and then another 2, because we haven't equal target, nor is sum greater than target. And we're still at 6, so then we'll have a 2 again, 2, and then now it's going to be greater, so we come back, we're going to pop the 2 off, and now we're going to try the 3. This process just continues because we have all these numbers like 2 6, and that's going to exist, and then we'll have 7, and then we'll try a different combination where you have 3. The thing is, like, this will go through, I mean, there's probably a way to make it exit sooner, but for now, I mean, I guess I could have an if condition within here, so that way we're not doing any more. And then there's also probably a way I could, if the array is sorted, if we don't actually know if the array is sorted all the time, I don't think it indicates that. But this will work for if it's not sorted. And we don't have to do the n log n operation at the beginning, but that could be an option that you do, and then you can make it fail sooner. But let's just try this for now. Output is empty. Am I not adding correctly? So I have let res here, cur push. I would be expecting I is equal to 0. Go through, then if it doesn't work, we'll pop all the way at the back. I believe we will at least. We have cur push, then we'll do helper. Index is here. When do I increment index? I don't. Oh, okay, yeah. So I have helper. This will go 2, 2, 2, and then 2 again. Then it'll return. Then we pop. And then index will try to for 2, 2, 2, 3. And then that'll eventually pop. Then I'll try 7. And then once we get to the end of the array, we're popping. And then we're going to pop the 3, pop again. And then we'll have a 3 in the array. And then we'll try the 3 with the index. So now index is 1. So I'll try 3, 3 again, and so forth. So where is it messing up? So if I have candidates.length, oh yeah, okay. Oh my goodness, I'm getting a lot of unnecessary prints. Am I not actually creating this array separate from itself? If I'm modifying the same one every time, that could mess it up. I thought this spread operator makes it separate. Res.push. Sum is equal to target. Okay. What am I missing? Alright, this is the point where I would check out the editorial. And let's see where my logic is flawed on. So path is my cur. Interesting. Huh, my method looks really similar. Res.push. Oh, whoops. Yeah, no, that's right. I should be returning here because I don't want to keep going. That's going to be redundant work. So this one should, okay, that's still really long. What is it that I'm messing up on? I feel like I'm definitely right there. So I start with 0 and I'm adding it, sum plus, yeah, candidates. So that's fine. Oh my goodness, I just realized I'm using the wrong number here, or wrong variable. I'm using index. My goodness. Okay, let's see. Okay, yeah, I mean that's, yeah, make sure to check your work. But yeah, that is kind of how I would solve it. Yeah, and then don't be afraid to look at the editorial at times. Like, there are cases where, I mean, your logic might work and stuff, and then it might just come down to debugging. But it's I feel like there's a lot more value that to, if you understand the problem and you are like really close to solving it, I guess. You can compare with like another solution, but don't necessarily try to copy it. Try to find where your errors are within your own code. I feel like that helps me understand uh, if there's something that I had like overlooked, or maybe like a variable was just like incorrect. It helps with like speeding up the whole process, because I feel like before I'd spent a lot of time just working on like one problem for way too long, when I could be easy, when I could have just looked up a solution to understand it better and then try again in like the future. But yeah, I mean that's how you would solve it. In terms of runtime, I feel like this is one of those uh, longer cases where you have, you're iterating through all sorts of different possibilities. So say if I'm on the very first index and we have a size of n, then I'm looking at it would be, so say n is 4, then I also have 3 here, then 2, then 1. Yeah, where I have n choose 1 and it's 4. So would this be, I don't want to say factorial. I think that's really big. Is it 2 to the n? Because I do this, and from this case I have 4 or n new subproblems, and then n minus 1 every time. So would that be, oh my, is it factorial? What is this? Okay, yeah, I have no idea what the time complexity is. I don't know why it's giving me like these weird numbers. It might be good to, I don't even know how I'd calculate this, to be honest. I'll be completely honest with y'all. I feel like in this case, you could honestly probably just Google what the time complexity or space complexities for backtracking is, because this is so strange. But yeah, I mean, that's kind of how I would approach the problem. And yeah, I hope that helps. Thanks for watching. Bye.